Good evening and welcome to Master Talker online class. If today is your first day of watching our video, please consider subscribing. Okay, so let's continue from where we stopped. They said F is equal to this, where G is what? Universal gravitational constant, M1 and M2 are masses, and R is their distance apart. The law in physics having such mathematical expression was given by Newton. Okay, this is Newton, so the answer is Newton. Very simple. So let's move to the next question. The next question, question number 23. Question number 23 said given the following, comma, G is equal to 9.8 meter per second square, R is equal to 6.4 times 10 raised to power 6 meters, comma, G is equal to 6.7 times 10 raised to power minus 11 Newton meter squared kilogram per kilogram squared, comma, calculate the mass of the earth. Calculate the mass of the earth okay, calculate the mass of the earth. Now if it's theory, then you have to solve, but if not, just know that the mass of the earth is 5.9 times 10 raised to power 24. As simple as that. Don't solve anything, just know that it's 5.9 times 10 raised to power 24. But if not, if it's a theory question, just know that what? F is equal to what? Gm squared over what? Over R. So put everything. We know that F is equal to what? Mg is equal to what? Gm squared over what? R. This M will cancel one of this M. So I'm having that okay, sorry. The mass of the earth is equal to what? G. How do I get the mass of the earth? Okay, the mass of the earth is the small letter G, because this will cancel one of these, so I'm having one here. So this will cross a G R all over what? G R. What am I saying? If this cancel one of these, so I'm having cross multiply. I'm having that Gm is equal to what? Gr. So my M is equal to what? Gr over what? Over G. So Gr squared. So there's squared here. So Gr squared over G. So put everybody 9.8 times this R is what? 6.4 times 10 raised to power 6 divided by what? 6.7 times 10 raised to power what? Minus 11. If you do everything, you will get the same thing I told you, 5.9 times 10 raised to power what? 24. Okay? In kilogram. So that is the mass of the earth. So alright. .9 times 10 raised to power 24. So I can clean the board. Question number 24. Question number 24 said the work done in taking a unit mass body from infinity to point R in the what? Can't see that. Think in the field of the earth rotation. In the field of the earth rotation is known as what? I think it's known as gravitational potential. It's known as what? Gravitational potential. Okay? So that is that. Question number 25. We are heading to the permanent side. Question number 25. Question number 25 said calculate the tensile stress in a copper wire of diameter 2.0 cm when it lifts a load of 100 kg. Solution. All right. I know that stress, tensile stress is equal to what? Force over area. Okay, and formula for area, first of all, they gave us diameter. Diameter they gave us is what? 2.0 cm, which is what? 2 divided by 100, which is what? 0.2 meter. Okay, 0.2 meter. But I know that what? 2 radius is equal to 1 diameter. So therefore, radius is equal to d over 2, which is what? 0.2 divided by 2, which is what? 0.1 meter. Okay, and the area is simply pi r squared, which is what? Pi is 3.142 times 0.1 squared, which will give you 3.142 times 0.1 times 0.1. So I'm having 0.03142, okay, in meter squared. This is the area. So the tensile stress is force. What is my force? Force is mg, which is what? 100 times g, which is 10, divided by what? 0.03142. So I'm going to have how many zeros? 4 zeros divided by 0.03142. So I'm left with, so the tensile stress is equal to what? 318,268.619. Okay, so that is that. So if you want to approximate, this is how many? 1, 2, 3, 4, 5. So this is what? 3.2 times 10 raised, approximately 3.2 times 10 raised to power 5. 3.2 times 10 raised to power what? 5. That is that in Newton per meter square. In Newton per meter square. Okay? 1, 2, 3, 4, 5. So that is that for that. The next question, question number 26. Question number 26, which says that the scalar product of force F and displacement S in the direction of the force, is the definition of work done. That's just work done is a scalar quantity. So, and the scalar multiplication or dot product, you know that dot product is called scalar multiplication. Dot product of two vectors will give you a scalar. Okay, So that is that. So the next one, question number 27. And question number 27 said, a body weighs 5,000 Newton, weighs 5,000 Newton, weighs 5,000 Newton, falls freely through a height of 1,000 meters. Then I say what is the work done? Okay, what is the work done? The work done is simply 4 times the distance. The work done is simply the 4 times the distance. Okay, which is what? Solution. The work done is simply force times the distance, which is what? 5,000. Force is measured in Newton, so force and weight is the same thing, times what? 1,000, which will give you 5.0 times 10 raised to 1, 2, 3, 4, 5, 6. 10 raised to 6, that is Newton meters or what? Or joules. It can be Newton meters or joules. Okay? So, but if you want it to be in kilojoule, you know that 5,000, 1,000 means kilo. So, which is what? 5,000 kilojoule. That is 5,000 with another 1,000. So, 5,000 kilojoule. That is it. You want it to be in kilojoule. So, the next one, question number 27. Okay, we just solved 27, 28. Question number 28 said 1,500 joules of work done in raising a block from the ground state to a height of 1.2 meters. Calculate the force on the block. Solution. Okay, we know that work done is force times distance. Work done is force times distance. So the work done is 1,500 is equal to the force I'm looking for times the distance 1.2. So my F is simply 1,500 divided by 1.2. So what do I have? I have 1250 Newton. 1250 Newton. So question number 29. Question number 29 said the energy a body possesses by virtue of its body atom is called a potential energy. Number 30. Question number 30. Question number 30 said the mathematical expression. Question number 30 said the mathematical expression for work done energy equation is dash. Solution. we know that work done is equal to NH, is it not true? So work done is equal to energy is still it can be the integral of mv dv, because if you integrate this it will give you 1/2 mv squared plus a constant. Okay, so and it can be work done is equal to what? 1/2 mv squared. In fact, this is the right one, because this one will tell you where it started from and where it ended. Okay, maybe I didn't they put from 0 to maybe v, then we'll choose this one. So let us choose this one. So that is that. So question number 31. Question number 31 will give you, they said the SI unit of pressure is named after great scientist called Pascal. A great scientist called Pascal. Blaise Pascal. Okay? 33. We are moving. Question number 33. We said a solid weigh 11 Newton when suspended in air, and 9 Newton when suspended in water. Okay, then I say calculate the volume of the solid. Okay, solution. We calculate the volume of the solid. Question number 33. This is very simple. We know that weight of water displaced is equal to the weight in air minus the weight in water, which is what? 11 minus 9, which is equal to 11 minus 9 will give you 2 Newton. Okay? Then you know that the mass of water displayed is simply you know that weight is equal to mg now. Weight is equal to mg. Weight is equal to mg. So the mass of water displaced is simply the weight divided by 10, acceleration due to gravity, which is what? 0.2 kilogram. Okay, now we know that density of water is 1 gram per cm cube. Don't forget, density of water, and if you change it into gram, you're going to have 0.2 times kilo means 1000 gram. Okay, which is what? 200 gram. Okay, so now we know that density of water is equal to what? Density of water is the same thing as 1 gram per cm cube. Okay, and I know that density is equal to what? Mass over volume. So what do we have? 1 gram, 1 is equal to, the mass there is what? 200 divided by what? You know why I used 1? Okay, let me show you. Since we are talking about water, the density of that object is same as the density of the water. That's why I used water there. Okay, because they didn't give us the relative density. They gave us the relative density, then it will help us. So we have that 1 is equal to what? Mass over the volume. So if you cross multiply, I have that the volume is equal to what? 200 cm cube. So that is the volume there. Question number 34. Question number 34 said a piece of metal weighs 200 grams in air and 100 grams in water. What will its weight in alcohol of relative density 0.8? Okay, so solution, you know that relative density is equal to what? The density of alcohol all over what? The density of water. So I have 0.8 is equal to what? The density of the alcohol all over density of water is 1. Okay, so which means the density of the alcohol is simply 0.8 gram per cm cube. Okay, so and they're asking us the weight of that object in alcohol. Okay, so another way we can use this, we can say that relative density is simply what are displaced, that is weight of that object in air minus weight of that object in alcohol, all over weight of that object in air minus weight of that object in water. Okay, did they give us something like that? Okay, so relative density 0.8 is equal to weight in air is 200 minus weight in alcohol is what I don't know, the weight in alcohol, all over weight in air is still 200 minus weight in water 100. So if I cross multiply, I'm going to have this is 0.8 is equal to what? 200 minus WAL all over 100. So if you cross multiply, you are going to have that 200 minus the weight in alcohol is equal to, this time this will give you 80. Okay, so 200 minus 80 is equal to weight of that object in alcohol. So therefore weight of that object in alcohol is 120 grams. So that is that 120 grams. Question number 25. Question number 35, sorry. Question number 35 said the force per unit length acting in a space, the force per unit length acting in the surface of a liquid at right angle to one side of a line drawn in the surface is called the surface tension. Yes, it's called surface tension. Okay, question number 36. We'll leave question number 36 for a reason. Question number 37. Question number 37 said a string. In our next video, I'll solve that. A string of length 5 cm is is extended by 0.04 meter when a load of 0.8 kilogram is suspended at the end. How far will it extend if a force of 16 Newton is applied? They said Hg as 10 meter per second square. Okay, and they said that a string of length, that's the original length of this string. The original length of this string is what? 5 cm. Okay, and they say that what is extended by 0. The extension is what? The extension is 0.4 meter. Okay, 0.4 meter. So if you change this one will give you 0.5 meter. Okay, so we know that extension is what? The length minus the original length. So this is 0.4 is equal to the length there minus 0.5. So the length which they extended it is what? 0.4 plus 0.5, which is 0.9. Okay, they say that when a load of this, let's call it force, the load of 0.8 kg times 10, which will give you 8 Newton, is suspended at the end. Okay, now they now say how far will it extend if a force of 18 Newton is applied. A force of 18 Newton is applied. So we know that F over extension is equal to what? How far? Okay, they say how far will it extend? Okay, F over this E is equal to what? F over E, 1122. So the first force they gave me is 8, which provided an extension of 0.4. Okay, is equal to, and they did remove the other force. They say if a force of 18 Newton is applied to this string, so that 8 plus the 16 plus 8 is the new force. Okay, 16 plus 8 will give you 24. So this is 24 all over the extension. I don't know. So the extension is now 24 times 0.4 divided by 8. So what do you have? Okay. Uh, 24 times 0.4. When did we get 0? Okay, 0.4 is the, sorry, this is 0.04. Not 0.4. 0.04 meters. Okay, 0.04. So 0.0. Okay, so that is 24 times 0.04, then divided by 8. So I'm having 0.12 meters. Okay, so that is the extension. So we don't even need that first calculation I did. That is the extension. So that is that. So question number 38. Question number 38 said find Find the potential energy of an object of mass 10 kg placed on a building floor 10 meters above the ground. Then I say take G as 10 meters per second square. Okay, solution. Now what do? We know that potential energy is equal to what? mgh, which is what? The mass there is 10 times the G is 10 times the height 10. So I'm having what? 1000 joules or 1 kilojoule. 1000 joules or 1 kilojoule. Question number 39. Question number 39. Question number 39 says calculate the time taken for a mango fruit that fall from the tree of 20 meters to reach the ground. Okay, so time to reach the ground is simply U over G. Very simple. And my U, do we have U there? Is there any? They said what? Calculate the time taken for a mango solution. They gave us the distance to be what? 20 meters. And that mango is falling from a tree, and they gave us G at 10 meters per second square. Okay, we know that what? S is equal to UT plus 1 over 2 GT squared. Okay, so since it's falling, it was at rest, so U there is 0. U is equal to what? 0 meter per second. So my S is 20 is equal to what? 0 times T will give you 0 T. This one is gone. So I have 1 over, okay, let me put it there. 0 bracket T plus 1 over 2 times 10 times T squared. So I'm having 20 is equal to what? This and this, 5T squared. So T squared is equal to what? 20 divided by 5. So T squared is equal to 4. So T is equal to what? Square root of 4, which is equal to what? 2 seconds. 2 seconds. Okay? So question number 40. Question number 40. Question number 40 said, if an object whose mass is 3 kg moves in a circular path of radius 0.9 meters, okay, moves in a circular path of 0.9 meters, comma, records a speed of 2 meters per second, then I say, what is the angular velocity of the object? Solution. So I have that the mass of this object is what? 3 kg. Okay, and then I have that okay, sorry, this is 0.7. I have that the radius is equal to what? 0.7 meters. Okay, and they said that the velocity is what? 2 meters per second. So they are asking us the angular velocity, but I know that normal velocity is equal to what? Or angular velocity times r. So angular velocity is equal to what? Normal velocity divided by r, which is what? Normal velocity is 2 divided by what? The r is 0.7. So 2 divided by 0.7 will give you 2.85, which is approximately 3 rad. 3 rad per sec. 3 rad per sec. So question number 41. Question number 41 said, what is the coefficient of friction between a wood of mass 1.6 kg and the horizontal surface, comma, if the limiting friction frictional force is 8 Newton. Solution. I know that coefficient of static friction is equal to what? Frictional force over normal reaction. And frictional force there is a limiting force. The limiting frictional force is what? 8 divided by the normal reaction is mg, which is what? 8 over 1.6 times 10, which is what? 8 over 16, which is 1 over 2. And 1 over 2 center what? 0.5. There is no SI unit because Newton will cancel Newton. So no SI unit. So the last question here. So thank you very much for watching. Bye bye.